In this video, we're going to see addition, subtraction, multiplication, and division of phasors. Basically, the first thing to understand here is that when you want to perform addition and subtraction, it is preferable you take all your phasors to J notation. So for example, if you're given a phasor in polar form and you're asked to add or subtract, it is preferable they are first of all converted to J notation, and so that your addition and subtraction can be a lot easier. Also, when you're given indentation and you're asked to multiply or divide, it's preferable you take them to polar form. Okay, I'm going to take a simple example now so that we can see how to perform these operations of subtraction, addition, multiplication, and division. Let's take for example that we have an expression v1 is equal to minus 10 plus G20, and our V2 is equal to 20 plus G30, and we are asked to perform addition of V1 and V2 and also to subtract V1 from V2. So doing this, you can see that this is already in complex form, that is genotation, and we just said it's preferable that we leave them in genotation when we are performing addition or subtraction. So perform addition and subtraction, all you need to do is to simply add the real components and add the imaginary components, and then you're good to go. So for the V1 plus V2, all we have to do is look at the real part of both, that is minus 10 plus 20 plus the imaginary part is J20 plus 30, which gives us 10 plus J50. You can see how straightforward we can perform this operation. Also, let's do for subtracting V1 from V2. So we have V2 minus V1, and this is simply going to be 20 here minus this. We have 20 minus 10. So now we are subtracting. So we do the same thing here. We plus this minus this. We have 30 minus 10. So we have J 30 minus 20. So we are left with 30 plus J 10. And that is simply how you perform the addition and subtraction of complex numbers. But if you are asked to do the multiplication, we just said to do multiplication, it's preferable we take them to polar form. Not that we can actually perform this multiplication this way, but when they are in polar form, it becomes a lot more easier. So very quickly, I'll just use the same example and perform the operation for V1 multiplied by V2, and also for V2 divided by V1. Let's see how this goes. So I'll just clean this up and let's see how to perform V1 multiplied by V2. So for the multiplication, all we have to do is first of all convert these our operations to polar form, from which we can then perform our multiplication and division easily. So let's see if we can convert this back to polar form. To convert this to polar form, V1 becomes the root of minus 10 square plus 20 square. It's an angle of tan inverse of 20 all over minus 10. And this, we can actually compute it using our calculator. This will give us 22.36, an angle of shift and next minus 63.43. Okay, so we've done that conversion. Okay, up next we're going to do the same thing. We try to convert V2 to polar form, and this we can do by saying 20 square plus 30 square is an angle of tan inverse of 30 all over 20, and this should give us the value of that is 36 at an angle of, so we perform shift and is at an angle of 56.31 degree. So now that we have our phasors converted to polar form, and see V1 now is in polar form and V2 is in polar form. To perform our multiplication, all we have to do is to multiply the magnitudes and add the angles. So in this case, for V1 multiplied by V2, all you need to do is to do what? Multiply this by this. What we have is 22.36 multiply by 36 at an angle of minus 63.43 plus 50 plus 56.31, which will give us 26 multiplied by 22.36 is 804.96 at an angle of minus 7.12 degree. So it is this simple and straightforward. But if we are performing division, our V2 divided by V1 can simply be gotten by dividing the magnitudes and then subtracting the angles. Very straightforward. So what we have here is now 36 divided by 22.36 at an angle of, subtract this from this, we have 56.31 minus 63.43, which will give us 36 divided by 22.36 as 1.61. This becomes 1.61 at an angle of 6.31 plus 63.43. Okay, so we have 119.74 degree. So that is simply how we can perform simple operations of addition, subtraction, multiplication, and division of phasors. But then, for the multiplication, we can as well do direct multiplication and we'll still get the same answer. That will be it for this video. In the next video, we'll actually try direct multiplication.